Atkins Civil 3D video series, Storm 2A, existing storm layout. This video illustrates A, create existing storm pipe network, B, lay out existing storm system and plan, C, modify pipes and structures. In many cases, the layout of the existing storm system is created in the initial stages of an improvement project using the survey points and the field notes. The layout is created on the storm improvement drawing. For this video, the layout of the existing storm is created from the existing topo drawing in which the structures and pipes are plotted therein. It is best to start the existing storm pipe network layout uphill and proceed downhill. The minimum depth of cover and minimum pipe slope contained in the pipe rules will provide a better initial profile of the network than if starting from downhill. It is also best to lay out the main run and then lay out the branch runs afterwards. A pipe run is created by initially picking the upstream structure and then picking each subsequent downstream structure. The escape key is depressed after the last structure in a run is picked. Storm drain systems associated with the road improvement project are created with the structures being referenced to the road alignment. An alignment is generally not created for a storm pipe network unless a profile is required that is separate from the road profile. In such cases, the alignment is created after the storm pipe network is created. Existing structures are given a number starting from 1, and existing pipes are given a number starting from 1. It is not necessary to create existing structures nor existing pipe with a logical numbering system. There will eventually be 2 pipe networks for the existing storm system. One network will be named EX-STRM and the other EX-STRM Demo. In some locations, new storm improvements will be constructed to replace the existing storm. Initially, all existing storm facilities will be created EX-STRM network. After creation of the storm improvements to be constructed, the EX-STRM Demo network will be created. The storm pipes and structures that will be removed will be merged into the EX-STRM Demo network. This will allow the deref of only that portion of the existing storm facilities that remain after demolition to be inserted into the other improvement drawings. Create the EX-STRM pipe network. Make sure the drawing is in world coordinate system. UCS enter. W enter. Home ribbon, create design panel, pipe network creation tools, network name, existing storm, parts list, existing storm, layer, existing storm, okay, surface, existing surface with aerial, alignment name, select the primary road, label style, existing storm plan, pipe label style, existing storm plan, okay. In the Network Layout Tools dialog box, structure type, select the first structure, the curb inlet, 48 by 60, pipe, 24 RCP, pipe slope is downhill, select pipe and structures, pick location of first structure. It does not have to be exact. They can be moved and rotated at a later date. Check the downstream pipe size and the next structure size and pick location. Check type and size of downstream pipe and next structure and make change in dialog box if needed. Pick location of the next downstream structure. Proceed picking the downstream structures. Next pipe downstream is a 30-inch. And a conflared end section. 30 FES. Escape. Create structures and pipe in the branch runs. If the pipe network layout tool dialog box is not displayed, pick a pipe or structure. Move cursor and right click, edit network, Pick the type of structure, curb inlet, 60 by 48. The previous one should have been 60 by 48. Normally, the length is parallel to the road and the width is perpendicular to the road. Size of pipe, 24. Toggle down slope, pipes and structures. Pick location of first structure. Check the size of the downstream pipe and the next structure. Make change in the network layout tools if needed. Pick. Continue picking downstream structure. To join an existing structure, hover over the structure until the connect glyph appears and pick. Escape. To modify the structure location, pick the structure and use the square glyph at the center to move the structure. Use the circle glyph to rotate the structure. When a structure is moved or rotated, all connected pipes remain connected to the structure. Draw temporary layout lines as needed for locating a structure at an exact location and orientation. Use object snap, intersection, to move the structure to the exact location, nearest, and for orientation of the structure. To modify the pipe location, pick the pipe and use the diamond glyph to lengthen or shorten the pipe along its current alignment. Use the square glyph to move the pipe away from its current alignment. When a pipe is lengthened, shortened, or moved, it is disconnected from the structure. To reconnect the pipe, pick the square glyph, hover over the structure at the desired location where the pipe is to be connected to the structure and pick. It may take several trials to locate the pipe at the desired location. To modify a part property, pick the pipe or structure and use the context-sensitive ribbon or right-click and use drop list to select the desired modification. The main modification includes swap part, structure properties, change the reference for the surface or alignment, adjust the top and bottom structure elevation, or adjust the elevations for the connected pipes. The reason that pipe 1 shows a warning symbol is because the pipe is connected at a location different from normal. Okay. The arch pipes contained in the parts catalog do not portray the width in plan view and the height in profile view correctly. For some unknown reason, the height dimension is shown in plan and the width dimension in profile. Reversing the width and height dimension in Part Builder does not help. Atkins used Part Builder and the elliptical pipes contained therein to create the horizontal elliptical corrugated steel arch pipe family with the width and height dimensions for the corrugated steel arch pipe. Only the width and height lines of a pipe are displayed in plan and profile view. The cross section is only displayed in section views and crossing pipe in profile view. At these locations, the arch pipe will be displayed as an elliptical pipe. Drafting enhancements will need to be made manually in order to show a true arch pipe. Add drafting enhancements to arch pipes in plan view. The outer boundary of a pipe network object is generally displayed on the drawing. At times, drafting enhancements are used to improve the appearance of an object. Drafting enhancements may not be required, but they greatly improve the artistic value of a drawing. On the current drawing, there are several existing corrugated steel arch pipes in which the ends have been beveled. Partial ellipses are drawn to enhance the appearance of these pipes. MA to start match properties. Pick the existing pipe, pick the ellipses. Escape. This video is a part of the Civil 3D video series created by Gerald Atkins of Atkins Engineering. Visit www.atkengr.com for instruction manuals, tutorial drawings, template drawings, and Civil 3D videos.